people might know what a linear equation is. Now, a linear equation is defined as so that's a linear equation. Linear equations are algebraic equations with one or two variables, where variables are all raised to the power one. So they're degree one equations. And also the feature of a linear equation is that it always, when we plot it on a graph, and later on in the lecture, I'll introduce you to the graphing of linear equations. And later on, we'll move towards the system of linear equation, where we will discuss more than two linear equations and plot them on a rectangular, something called a rectangular coordinate system. And that gives us the solutions towards these system of linear equation or a simple linear equation. Now, linear equation in essence is basically it describes the relationship between two variables, in this context x and y, between two variables x and y. And so a few things once more. What are linear equations? So for instance, if I write 3x plus 2y, and maybe that is equal to 6. So right here, you see the variable part, x and y, they are raised to the power 1. So if the variables are raised to the power 1, then such equations are basically called linear equation, abbreviation LE. Now, what if I write it something like this, 3x squared plus y, then to some value, right? Let's suppose it's 20, right? So right here, the exponent of x is a square and the exponent of a y is 1. This equation right here is basically a nonlinear equation. Now, we discussed that in a fair bit of detail in your regular lecture. The aim today is to introduce you to what we call the rectangular coordinate system. So what is a rectangular coordinate system? This is also called Cartesian coordinate system. In a Cartesian coordinate system is basically the combination of two lines. So a vertical and a horizontal, and it basically intersects at this point right here, which is called the origin point. Now, if you move towards the right hand side of the origin, we get the values which are the x values, and we get positive value of x. And when we move towards the left-hand side with reference to the origin point, we basically get something called the negative value of x. So the horizontal line, this line right here, it represents the value of x. Now, the vertical line, if we move above the origin, we call all of these points as y values, and these y values are positive. And if we move down below the origin, so we get the value of y's which are negative. So in other words, the rectangular coordinate system or the Cartesian coordinate system constitutes two lines, one vertical and another one a horizontal. And this system is also called a rectangular coordinate system. Now, one thing should be clear at this point. So for instance, if I put any point anywhere on this rectangular coordinate system, so I'm putting some points, and you can put them anywhere. Each point on a rectangular coordinate system will give you two values. So for instance, if I consider this point right here, then we can extend this point down below towards the x-axis, and we can extend that horizontally, and that will give us some value of x and some value of y. So some value of x and some value of y. So each point on a rectangular coordinate system gives us the value of x and y, and we call that combination of x and y as ordered pairs. These are what we call the ordered pairs. Later on, I'll introduce you to the ordered pair. That what's the function of ordered pairs? The ordered pair basically helps you to what we call satisfy the equality of the linear equations. So that's the ordered pair, and always in ordered pair, the value of x comes first, and then comes the value of y. So this region right here, which I am highlighting with this orange color, so all of this region right here, all the way, this is what we call the first quadrant. This is what we call the first quadrant of the rectangular coordinate system. This region right here, beside the orange one, the blue one, anything in between, this is what we call the second quadrant. That is the second quadrant. So the counting in the rectangular coordinate system is anti-clockwise. And similarly, this region right here, this specific space, on a rectangular coordinate system, all of the points right here, that is what we call the third quadrant. And this region right here, all of it, let me highlight that, that represents what we call the fourth quadrant, right? So each quadrant represents some combination of X and Y if we put a point on the rectangular coordinate system in the corresponding quadrants. So that is what we call the fourth quadrant. So for instance, if I put any point in the first quadrant, so the ordered pair in the first quadrant, any point, right, it will represent some value of X and some value of Y. Since the value of X, if we take even this point and if we drop it down, the value of X is some positive value and the value of Y is some positive value. So the ordered pair from the first quadrant will always have the value of X that is positive and the value of Y that is negative. If we move towards the second quadrant, so in the second quadrant, if we pick any point, so each point on a rectangular coordinate system represent two values, X and Y. In combination, we call it ordered pair. That would be some negative value of X and some positive value of Y. Why? Because the Y extends above the origin, gives you a positive value, and the X that extends towards the left side of the origin gives you the negative value of X. Similarly, if we put any point right here in the third quadrant, so the third quadrant will always give you the value of X that is negative. And similarly, if we extend it to the Y axis, corresponding Y value will be a negative. So right here, we'll get both values that are positive, X and Y. So the ordered pair is a positive and a positive value for X and Y respectively. Right here, you will get the negative value for the X, but a positive value for a Y. And right here, you will get a negative value for the X and a negative value for a Y. And right here in the fourth quadrant, we'll get a positive value for a X and a negative value for a Y. Since if I take, let's suppose, any point near to the origin, away at extreme, so if we trace it across, that's the positive, that corresponds to a positive value of X and a negative value of Y. This is what the points look on a rectangular coordinate system. However, what about these points right here on the axis? These 4 points right here, these are special ordered pair, and these are basically intercepts. So if we take this point, at that particular point, it's a very special point at which the value of Y is 0, but you got the value of X, which is basically a positive, right? Similarly, if we take this point right here, at this point, you got some negative value of X, but since it's on a negative X-axis, there is no Y value. So if we go down below towards the origin and go towards the left, so we only get a negative value of X, but the Y value is 0. And similarly, if we go up above the origin, this point right, this point right here, this point basically corresponds to the value of X that is 0. Since it's the X-axis, we go towards the origin and we go up above. So we got the X value that is 0, and we got the value of Y that is some positive value. This is what we call the Y-intercept, right? This is the Y-intercept value. Similarly, if we go down below, let's suppose this point. So any point on the axis would basically give you some value of X, maybe positive or negative if it's on a horizontal axis. So anywhere, here, or anywhere, just excluding the origin, because at origin, both the value of X and Y, they are a 0 and a 0. That's the starting point of any line. Now, so that is about the rectangular coordinate system. Now, we discussed in our lecture that the linear equations can be represented in primarily two forms, right? We represent those in two forms in order to understand the graphing, and later on finding the solution of a system of linear equation, you need to be aware of what we call the forms of a linear equations. So linear equation basically got two forms. The first form is what we call the standard form. That is what we call the standard form. And another form is what we call the slope and intercept form. The slope and intercept form. Now, you should understand whenever I say intercept, what does intercept mean? Intercept might mean two things. Either the value of X is 0 and the Y has either positive or negative value, or the value of Y is 0 and the value of X and so intercept basically mean that if we get an ordered pair X and Y, so one of the variables value is basically 0. So if Y is 0, then we will get either the X value that is positive or X value that is negative. This means primarily we are moving on the X axis. So if it's the other way around, if the X value is 0, nothing on X, and the Y value is either positive or negative, so we are going up and down on the vertical axis, that is the Y axis. This is what the intercept mean right here. Right here, the slope and intercept form, we also write it in this form: y is equal to mx plus b. Later on in your courses, when you'll come across the statistics, this is what the regression equation, the linear regression equation, simple or multiple linear regression is basically constructed in such form. Now, what is a standard form? A standard form is when we say that the coefficient. So if I write x, right, x is a variable, the coefficient of x is 1. So if we write the equation something like this, 2x plus 3y is equal to 6, right? So since the exponent of x is 1, the exponent of y is 1, one thing is established: it's a linear equation. Now, when the variable multiplied with its coefficient and a variable multiplied with its coefficient, since we are only discussing the linear equation having two variables, x and y, right? And on the left hand side, you got a coefficient multiplied with a variable, and on the right hand side, you got a constant. Such form is what we call the standard form. So the standard form, the generic standard form of a linear equation is represented as something like this: capital A into small a plus capital B into small b is equal to C, where A and B represents the value of coefficients, while the value of small a or small b represent the variables, while C is the constant. So if an equation is written in such form, so that's the constant. So if the variable is, so if the equation is written in such form, this form is what we call the standard form of a linear equation. Equally important, what's the application of writing the linear equation in a standard form? Later on, when I'll introduce you to the system of linear equation, then we'll either move towards the standard form or the slope or intercept form. Now, what is this form, the slope and intercept form? Before moving towards the slope and intercept form, let's discuss a small case about the standard form. So, for instance, if we have an equation something like this, so let's take an equation in maybe in a fraction form. So, for instance, that would be something like this. So, if I say 2 over 3, if I say x, the first variable, plus a half of y, and if I say minus 3 is equal to 0. Now, how can we convert that into a standard form of a linear equation? So we are considering a standard form of a linear equation. So you can pause the video and you can try it out, that how can we write this particular equation in such form or in this form. So it's really simple. All you need to do is take, and we talked about this in your algebra module. You just take the LCM of the denominator. So the denominator right here is a 3 and a 2 and a 1. So in a 2's table, we get a 1 and a 1, and then we get a 3, and that's a 1 and a 1 and a 1. So 2 into 3, that's a 6. So multiply with each term 6. So what if I do this? So 2 over 3 x into 6 plus a half of y into 6 minus 3 into 6, right, equal to 0. Now start canceling it out. So 3 and 2, so 2 into 2, that's a 4x. Plus if I do this, so 2 and 6 and 3, so 3 into 1, it's a 3y. So that's the minus sign, and 6 into 3 is a 18, and that is equal to 0. Now, what are we supposed to do? So that's the coefficient, that's a variable, that's the coefficient, that's a variable, but that is basically a constant. So we are supposed to bring the constant towards the right-hand side. So how do we do that? And we discuss that in algebra. So it's a negative 18. So if it's a negative 18, so what if I do if I write a positive 18, so I'm doing that on one side of equality, I'm supposed to do it on the other side. That's cancelled out. So what's left right here? 4x plus 3y and is equal to 18. So the standard form of this particular equation right here, which is linear in its specification, is 4x plus 3y is equal to 18. Now we can basically plot this particular equation on a rectangular coordinate system.